All right, this is the Thanksgiving break homework that you should have been working on over the break. I'm actually going to collect this tomorrow, so I don't want you guys to have all of the answers. I'm going to give you guys one of the answers from each section, and then I'm going to have you guys do the other ones, and I'm going to actually grade it to see how you guys can do on it. So looking at this first one, it says the first derivative of the function f is defined by, and then it gives you the first derivative there on the interval from 0 to 2. It says on what interval is f increasing? So first, before I even look to figure out what interval f is increasing on, I'm just going to try and figure out how I'm going to go about figuring out this problem. So if I'm looking at what interval this is increasing on, if I'm given the first derivative, I know that the original function f is increasing wherever the first derivative is positive. So essentially I need to look for where this function is positive, or in other words, where it's above the x-axis. So I'm given the x values that I'm looking at from 0 to 2. I'm going to go ahead and plug this into my calculator. And when I plug it into my calculator, I'm going to look for a good viewing window. And a good viewing window for the x numbers is from 0 to 2. From 0 to 2, obviously. And you can kind of fiddle with the y viewing window, but the one that I found out worked the best was from negative 1.5 to positive 1.5. So this is the window that I chose for my graph once I actually input the function into y1. And then once I did that, I actually graphed it, and I got something that looks like this. And so this is the graph of the function. And again, this is the graph of the first derivative. So if this is the graph of the first derivative, to figure out wherever the original function is positive, that would be, wherever the original function is increasing, that would be where this derivative is positive. So I'm looking for whatever this x value is, and whatever this x value is, and it will be increasing in between those two x values. So you can either do it two ways. You can either use the calculator feature to find the zeros, or, because it's a multiple choice problem, you could probably just use the trace feature. And the trace feature should get you close enough to what the actual answer is that you wouldn't actually need to go through find the zeros. So it looks like the first one I found was 1. So 1 is probably the starting point. And if you go back and look at that Thanksgiving break homework, it looks like the first two answer choices, A and B, both start with 1. And then if you just move your cursor over with trace to figure out where the other 0 is on the other side of this little hump, I guess you could say, that will be where it crosses over into the negative numbers. And so what I got for that one, and I get this isn't perfect over here, and again, just because I'm using the trace feature, it's not exactly 0, but it's close enough to 0. And so 1.691 looks like the other one. So it's positive in between 1 and 1.691. So that would be my interval where the original function is increasing. So that looks like answer choice B, from 1 to 1.691. Oops, let me highlight that for us. Perfect. You could have tried this one if you would have typed in 1.445 on trace. You would have seen that it was definitely still in that hump region, and it wasn't actually a 0 yet, so that would be too far. And it definitely needed to start with 1, and none of these other ones do, so B is the only answer choice that actually works. Alright, so that's number 1. I'm going to let you guys try these other ones in this section on your own. So there's 1, 2, 3, 4, 5, 6 more problems in that curve sketching section. And again, I want to see how well you guys can do on your own, so I'm actually not going to go through those answers with you yet. I will do them later. Straight line motion. It says a particle moves along a straight line with velocity given by this function at time t greater than 0. What is the acceleration of the particle at time t equals 3? Excuse me. And again, I know that the acceleration of a particle is the second derivative of the original function, but if I'm given the velocity, it's the first derivative of the velocity. So essentially they're giving me a function, the velocity function to be specific. They're giving me a function and they're asking me the acceleration at a specific time. Well, this one's actually super easy to do on my calculator, because if I'm given velocity and I need to find the acceleration, that's just the derivative of the velocity function at this time. Now, obviously this is in the calculator section because this function is not super easy to take the derivative of, so we're going to have to use a calculator to take the derivative of it. So go ahead and type this function into your calculator. So after you type that function into your calculator, we can look at a couple different things. So the first thing we're going to look at is, we'll look at the viewing window that I put into my calculator. And honestly, the viewing window, as long as you have, and I'll show you what I put for mine. For the x values, I chose from 0 to 4, because it told me that it has to be greater than 0, and then I chose 4 because they wanted to know what the acceleration was at 3 seconds, so I just chose a number a little bit bigger than 3 so I could fit 3 on my viewing window. Now, honestly, y min, y max, your calculator doesn't really care what your viewing window is, and I just put that on there so you guys can see it on my graph. So I put from 6 to 6.25 just so I could see a nice curve in the graph and it didn't look just like a straight line if I zoomed out too much. But honestly, you don't even need to really worry about the y values. Your calculator will still find the derivative for you without getting a good viewing window. As long as you have from 0 to 4, it could probably care less about what the y min and y max were. But again, I did it for the sake of you being able to see what this graph looks like. So I went ahead and did that. So this is a viewing window that you guys can see right here. And you can see a nice curve to it, and this is a very small viewing window from 6 to 6.25, which means that if I zoomed out, it would kind of start to look more like a straight line because it doesn't curve very much. And then here's from 0 to 4. So I'm essentially looking for what the derivative of this line is right about here. So the slope of the tangent line right about here. Remember that your calculator can find the derivative for you. So if you go into second calc, and you go down to the sixth value, which is dy dx, that will find the derivative for you. So dy dx is just the derivative. So you go ahead and push that button, push the sixth value, take you to dy dx, and then type in 3. So I didn't take a picture of that, but it'll ask you for a value. Type in 3 and then push enter, and it'll tell you dy dx at 3 is 0.0545879. So 3 decimal places, that would be about 0.055 or 0.054. And so that answer choice here, it looks like, is answer choice B. So 0.055 is that answer choice. And again, sometimes it is that easy where you just have to have your calculator determine what the derivative is for you. It's not really much work on your part. All right, there's 2 more problems in this section, so I'm going to have you guys try those ones on your own. Average value, we haven't talked about this one too much, but it does come up quite frequently on the AP test, and it's not a hard thing to do. It's not a difficult thing, I should say. This one might require a little bit more help from my end, so I'm going to do the first one with you guys, and then I'll have you guys try the second one on your own. So it says, what is the average value of y equals this function on the closed interval from -1 to 3? So first things first, I want you guys to put this into your calculators and then look at it on the interval from -1 to 3, see if you guys can get a good viewing window. So if you type this function into your calculator on the interval from -1 to 3, I found a viewing window that worked for me, and that was, oops, let's go back in here to the viewing window one more time. The viewing window that I found that worked best for me was right here. So from -1 to 3, and then I chose from -0.5 to 1, and when I did that, I got a nice view of this function. So when I graphed that, I got something that looks approximately like this. So it gives me a nice picture so that I can see my graph pretty well. You guys can see that it starts here and then kind of goes up and then back down again. So this says average value. We haven't talked about average value too much in this class, but average, and if we were in our classroom right now, I would point up to the wall because I have the instantaneous rate of change on the wall, and it right below it says that it's the tangent line, so that would be the derivative, is the instantaneous. We talked about this at the very beginning of the school year, but essentially instantaneous is something that happens at a moment, and so that's why we need the derivative for that, because we only want to look at it at one point, what's happening at exactly one point in time. The average value, however, and I have this up on the wall right next to it, it says that the average rate of change is like the slope. So this is something you've known how to do back from like algebra. And so the slope is just, the formula for slope, y2 minus y1 over x2 minus x1. And so that's essentially what we're going to do here. So you have 2 options for how to do it, and it kind of just depends on how comfortable you are with your calculator. Option number 1 is you could go through trace, and you could actually figure out what the x and y coordinates are at each of the 2 endpoints, because they want to know the average value between -1 and 3. So the first thing you could do is you could go and push trace and figure out what the value is at -1. So I went and showed you that here. And you get that the value of -1 is about 0.270. So you could write that down on your paper, and you could do 0.270 and then -1 for the x value. So you'd have an x and a y coordinate pair here. And then you could go back and do that again with 3. And you could say, okay, so for 3 I have 3 comma -0.071 approximately. And you could write that down for an x and y. And you could just plug those into the slope formula. So you could do y2 minus y1 divided by x2 minus x1. Or, and the thing I want you guys to practice doing is I want you guys to practice getting faster at your calculators. So the way that I would want you to do it on your calculator is like this. And so I'll try to walk you through it step by step as best as possible. Because I just would rather have you have the calculator calculate it for you. Just, I mean, if you're comfortable with it, of course, but just because your calculator is more accurate most of the time, as long as you put things in correctly. You don't have to write anything down. You might make a mistake if you write something down and things like that. So here's the way you would have your calculator do it. Go back to the main screen, and there's this button right here. It'll come up, hold on. There we go. There's a button right here that says vars, alright, and vars stands for variables. So on the main screen you're going to push vars, and then it'll come up and it says y vars, and I'll show you that one. It's default over here on vars, so move it over to where it says y vars, and you're going to click on function. So move it over to y vars, and then push 1 for function. And then you're going to want the first function. So the first function that comes up is y1. So here under function, you're going to put y1. Alright, and so what that's going to do is it's going to input y1 onto the main screen. So essentially you're recalling the function that you put into y1. And we already know that we put in that cosine function into y1. So it recalls y1, and on the main screen you guys can see that it pops up a little y1 just like this. Alright, so you're going to tell it what to plug into y1. So right now it's just recalling the function, which is like cosine of x divided by x squared plus x plus 1, or whatever that function was. So right now it's just recalling the function. So you're going to put parentheses, and you're going to say find y1 of 3. So you put, it already has the y1, so you just put open parenthesis, 3, close parenthesis. So what this says, and don't push enter yet, but if you did push enter right now, what this would be is just, it would evaluate what the function equals at 3. So this is like my, I'm plugging it into the slope formula. This is y2 minus y1 over x2 minus x1. So this is y2 because I'm plugging the second value into the function. And then go ahead and push minus and go through that whole process again. Vars, y vars, function, y1. So you have this written on your calculator. So here I have y2 minus y1. Alright, because I'm plugging in the second value minus plugging in the first value. So this is like the top of the slope formula, y2 minus y1. And you just have to be careful, because if you don't put parentheses around this, it's going to mess it up. So what I like to do is I like to do the top of the fraction first, and I'll push enter. So push enter and get an answer, and then we're going to divide it by what we would put on the bottom. So this is y2 minus y1, and we're going to divide it by x2 minus x1. So here's what I got for the top of the function. I pushed enter, and then I pushed divided by. Notice that it just recalls the answer immediately. Push divided by x2 minus x1. So x2 is 3 minus x1 is negative 1. So 3 minus negative 1 is dividing it by 4. And the answer you get for this is negative 0.085 approximately. And so that's our answer. This is the slope formula, y2 minus y1 divided by x2 minus x1. And so you could have done that, and you might even think that it's easier doing it the other way, where you actually write down the coordinate points and then just type them into your calculator. But sometimes it's easier to do it that way, sometimes it's easier to do it this way. It's just kind of up to you. But the other way, because you're rounding intermediate answers, if this was not a multiple choice question, I would not suggest doing it that way. Because if you're typing in the actual y values that you got from trace, those are rounded values. You rounded them to 3 decimal places. So when you plug them into here, you're not going to get the exact answer. You're going to get a very, very close answer. But if it was a free response question that it was asking you to do it for, a very, very close answer might not cut it. So that's why I wanted you guys to practice doing it this way instead, so that you guys could get practice having your calculator calculate the slope for you, rather than you finding 2 separate points and estimating their y values and then doing it that way. So this is a more accurate way of doing it. So the answer is negative 0.085. Excuse me. Which it looks like is answer choice A. Now notice that that's the only one that's negative, actually, so we probably could have just eliminated the other answer choices from the very beginning, because the first point was higher than the second one, so obviously it was going to have a negative slope. So if you noticed that from the very beginning, great, but if you did not notice it, then it would have been necessary to do it this way. So that's perfect. Go ahead and try that next one. For the miscellaneous ones, because these are all kind of different, I'm going to try and see if you guys can get those on your own. So there's 4 of those. I'm not going to necessarily go through those with you. And then the last thing I want to do with you guys is I want to go through one of each of these. So there's a numerical derivative, finding extrema, and then storing and retrieving a function, storing exact values. So most of these actually I think you know how to do, so I might not even go through some of these with you. Like, for example, the numerical derivative. I already did that with you guys today. Alright, so It says, use a calculator to solve the following problems. Write the calculator setup for each problem. So, evaluate the derivative of this. Pretty much all you have to do is type that function into your y1, and then go through at the graph and push, second calc and go to dy dx, just like we did on that problem earlier, and type in 4, and it should tell you what the derivative is automatically. So like I said, I'm going to skip this one because we already did this one once today, so I think you guys can try that one on your own. All right. Finding extrema and roots and zeros. Notice that it has this little gray box right here. It says, use this for exploration only, not as the sole means of finding an answer. I put that there because on the free response question, sometimes you'll be asked to do this on the free response questions. And it'll be on the calculator section, but this is one of the things that you're not, I repeat, you are not allowed to use your calculator to find zeros and roots and x-intercepts as the only way. Like if they want you to do it on a problem, you actually have to do it from the beginning and show your work for it. They will not accept just the calculator answer. So you can do it by hand, and then you can have the calculator check your work for you so that you feel confident in your answer, but you cannot have this be the only way you find extrema, zeros, and roots and x-intercepts. And again, I think we've actually practiced this one in class enough times that you guys could figure out these ones on your own. So it says finding extrema, zeros, roots, and x-intercepts. Here's some directions for you in case you need help, but I think you guys can do that because we've done it a few times in class already, and I want to see how well you guys do those on your own. So essentially, go and find the extrema. So find the maximums, find the minimums, find wherever it has, x-intercepts, and remember that these three words are synonymous. Zeros, roots, and x-intercepts, that's all one thing. So essentially these four, just want you to find the maximum, the minimum, and then the x-intercepts using your calculator. This one we just practiced, storing and retrieving a function. So remember that it says use a calculator to solve the following problems. It says find the average rate of change of negative 80 over the square root of x on this interval. So we literally just did that on the last problem. So type this function in, and then use that slope formula, y2 minus y1 over x2 minus x1, but do it in your calculator. So don't estimate it by hand, do it in your calculator so you guys can get as accurate as possible of answers. Alright, I think this is the only one we have not done yet. The storing exact values. So I'm actually going to go through this one with you. It says how to do it on a TI, which is the calculators you guys have. Find the value on the screen, push store, da-da-da-da-da. From now on, you can recall that value by pushing that. So here's essentially what it is. I've told you guys before, and I'm sure I will tell you again, but you are not allowed to use intermediate answers when you are solving problems on the AP test. So essentially, if you find an answer that you want, but it's not the final answer, you can store it, and this is going to teach you how to store it really quick, or you could just kind of keep it as the original answer before you simplified it. So let's do one of these together, and I'll kind of show you what I mean. It says store the number ln of 3.1 into your calculator, then use that stored value f of ln of 3.1 for the function that's given right here. So here is what I want to show you. So I think this is a pretty cool function, especially because it's not something you guys are probably familiar with yet. So it says that essentially you can store a value into your calculator and recall it later. So it says with the value on the screen, push store, and then push this xt theta n button. So I'm going to store ln of 3.1 into my calculator. So here's how I go about doing that. You're going to push ln of 3.1, so like that. Type in ln of 3.1 onto your calculator. And then there's a button down near the bottom, right above the on button. There's a button that says STO with a little arrow. So STO with a little arrow stands for store. So you're going to push that, and you'll see a little arrow pop up on the screen up above. And then you're going to push where you want to store it. So right now we're going to store it as our variable. We're going to store it as xt theta n. So you're going to push that button. And here's what you'll see up above on your calculator. You'll see that you want to store ln of 3.1 as x. So now every time you recall x, it's gonna recall this stored value, which is ln of 3.1. If you push enter, it'll tell you what ln of 3.1 is, and it'll let you know that it's stored there as x. So for example, You can see right here, I pushed enter and I got 1.1314. So what you're going to do now is it says to type it into that function. So 3x squared minus 4x plus whatever it was, 7. So the cool thing about this is that you don't have to actually do anything specific. Notice that I can just type in that function. I can type in 3x squared minus 4x plus 7. And because I stored this value as x, as soon as I push enter now, it's going to evaluate this equation for the value of ln of 3.1. So I push enter, and I get 6.3146. And that is this function evaluated at ln of 3.1. So all this is doing is storing a value in there for you. Like, obviously this, if you rounded it to 3 decimal places, would not be an exact value. And we always want our things to be exact values, or else that our final answers will be wrong. So if you get a number that you want to store into your calculator and you don't want it to disappear, but you don't want to have to, write it out to 15 decimal places, you can just store it in as x. And notice, by the way, that it says you can do it multiple times. So it says if you would like to store multiple values, follow the similar steps by pushing store. But then instead of storing it in x, t, theta, n, you can push alpha. And then you'll notice that the green letters underneath the keys, there's a bunch of green letters. You could store up to like 26, more than that actually, but 26 different values. And you can just store them under all those letters. And you would recall them the same way. Just instead of pushing X, you would push whatever letter you wanted. So let's say you stored like 3 different numbers. You could store them under A, B, C. And then just recall A, B, and C as you wanted to as you're doing your problem. And so this is helpful, like I said, so that you don't actually have to round intermediate answers as you go. So then you guys can try that last one. Alright, I just wanted to get you guys started on some of them to make sure you're doing the right way, but like I said, I will collect this tomorrow to make sure you guys are doing it correctly.